Welcome members to this lesson. Today we are going to see remainder theory. Now, don't forget to subscribe please to the channel. If you have a polynomial being divided by a divisor, say d of x, a factor of x, now using long division, we put our d here, the divisor, then the polynomial inside. Then when we divide, what we get is the quotient. What we get after subtracting what we've been dividing is called the remainder. Now, our polynomial p of x is always equal to the divisor times the quotient now plus the remainder. This is very crucial. Now, if the polynomial is divided by x minus a, now this x minus a is always called a factor. Then when we equate this factor to 0, what we get is a root. Now, if we put a root in a polynomial, what we get is the remainder, and hence the remainder theorem. You also need to know the relationship between the divisor and the remainder. If we have a linear divisor, a linear meaning the highest power is 1. If the divisor is linear, or the remainder is a constant. If we have a quadratic divisor, meaning if the highest power of the divisor is 2, then the remainder is linear. If we have a cubic, the remainder is quadratic. You see that the relationship always is, the divisor is always, the remainder is always the power less by 1, the divisor. This works if the polynomial is x is of power n, and the divisor is n minus 1. Examples. Find the remainder when the polynomial, this is divided by this. Now, this one is our polynomial, so our p of x is x squared minus 3x minus 5. Now, x plus 2, we say, is always a factor. Now, we need to get a root. Our root, we get a factor to 0. So, my x plus 2 equaling 0 is that my root is going to be negative 2. Now, if I put negative 2 into this, if I put the root into the polynomial, what I get is the remainder. So that's how I'm going to get my remainder. Meaning that now, my p of negative 2 will always be my remainder of x. And because the divisor, the polynomial is quadratic, the divisor is linear, it means that my remainder is going to be a constant. Now let us see. Now I'm going to substitute this where there is x, I'm going to put negative 2 in this equation. So I'm here now. Negative 2 squared minus 3 into negative 2, then minus 5 equaling to my remainder of x. Now this will be a 4 plus 6 minus 5 will be my remainder. And so here my remainder, when you get 10 minus 5, so that my remainder is 5. So the idea is just when you substitute in a root into the polynomial, what you get is a remainder. When I come to this, I say let my p of x be. Now I need to get the root. To get the root, I just equate the factor to 0. 2x equaling 0. So when I take this side, x becomes a half. So meaning that when I put the root into the polynomial, what I get is my remainder. This is what we call the factor, the remainder theory. So now my remainder will be remainder of x. I'm going to put where there is x, I put a half in this function. So here I'm going to do a half squared minus 5 into a half, then plus 1. This will be 3. This is our quadrant. Minus 5 over 2 plus 1. And then you simplify this. You see the LCM is 4. See the LCM is 4. 4 goes here. 1 times this is 3. 2 goes here. That is how many? 2 goes into 4 times, and this will get 10. Then plus 1. And you see, this will be negative 7 over 4 plus 1. And and cross multiply, this is the answer we get is negative over that. So the remainder when it's divided by this is this. In my new, in the next lesson, we are going to see what if we have a quadratic divisor, this is a linear divisor. Are you students? Look out for the next lesson. It will be lesson 2. Don't forget to subscribe.